Welcome to lesson 7.14. This lesson is going to be about the importance of soil organic matter and its impact on root-feeding nematodes. We're going to examine how we can improve the balance in the soil ecosystem in a practical way in order to mitigate the imbalance that is normally created in agricultural systems, causing an explosion of root-feeding nematodes. Okay, so without further ado, let's jump into lesson 7.14. So several studies show that there is a direct link between increasing soil organic matter and reduction of plant parasitic nematodes or herbivorous nematodes. And there was a review done in 2002 which focuses on the various methods that can be used in order to increase organic matter in the soil as well as suppress plant parasitic nematodes. And this lesson is basically based on that review. So obviously, to increase organic matter in the soil, we need to have plant matter. And the best way to have plant matter in the soil is to plant it. So basically, growing plants and allowing those plants to be turned into organic matter is what will increase organic matter in the soil. And for this purpose, of course, we need to first of all choose nematode-resistant varieties of plants if we are wanting to not support further reproduction of particular root-feeding nematodes that we might have a problem with. So this means that appropriate cover crops can be used that actually do increase soil organic matter if they are grown with the crop or at times when the cash crop is not growing. And this image shows an example of that. Using antagonistic green manures, so plants that actually deter nematodes. And here is an example of a green manure being incorporated into the soil. And using antagonistic plant residues leads to the creation of suppressive soils. And of course, having suppressive soils leads to reduced damage below nematode economic threshold density. So we will cover now each of these farm practices in relation to plant parasitic nematodes. So let's look into crop rotation, which is a practice that has been used for as long as agriculture has been around to reduce pests and diseases in the field. And crop rotation means that we grow other crops, not just one main crop. So each time a crop is harvested, another crop is grown, and it can either be grown to restore the soil or it can be grown as a cash crop as well. And we can use resistant crops as part of the crop rotation. And these resistant crops are normally the same species as the primary crop. And this is thought to be the most economical way to control nematodes because it leads to a commodity that you can sell. However, intensive use of resistant crops can actually select for aggressive pathogens. And sometimes nematodes might break through that resistance as well. So there is a fine balance as to the length of time these crops remain resistant. Also, resistant cultivars are largely unavailable for some species of crop, and this is when we need to use either non-host species or those that are poor hosts to the nematode in question. In general, crop rotation increases nutrients and microbial community structure, density, and distribution. Many plants that are used in crop rotation produce specific exudates that actually increase microbial activity and diversity and once again contribute to creating nematode suppressive soils. However, there is a requirement for an increased rotation complexity if there is more than one plant parasitic nematode species present within the system. And this requires knowledge of the nematodes, the host plants, as well as the particular environment within which they live. The practice of crop rotation using non-host crops can also be utilized. These include plants that the nematodes cannot feed on, are often immune to particular nematodes, or are inefficient hosts. And this can reduce diseases as well as damage to the main crop. Usually these crops are a different species to the primary crop, and crop rotation is known to reduce nematode numbers but the crops themselves may not be marketable. It is known to increase diversity and stability of rhizosphere microorganisms because you're now adding diversity of plants into the field, and you can increase the number of crops to increase soil structure and nutrient cycling, and therefore support a greater yield of your main crop. And here is an example of what a crop rotation might look like using a variety of different crops. So let's look more closely at different types of cover crops. They can be planted between annual cash crops and are typically grown outside of the growing season. And oftentimes cover crops include things like vetch, cowpea, crotalaria, Sudan grass, which is a relative of sorghum, marigolds, and this is a marigold flower pictured here on the right, rye and wheat. And they are planted with the intention of increasing soil quality, to control erosion, and also to reduce perennial disease problems. And if you have a nematode issue in the soil, you would want these plants to be nematode resistant. Many nematodes, however, have a very wide host range, and there are only several that are limited to a few plant families or species. So therefore, it is essential to know what kind of nematode you have and what kind of plants it likes to feed on. Cover crops are planted between primary crop cycles to reduce the nematode numbers. You can choose some cover crops which display allelopathy, which is the chemical signal or a release of toxins into the soil ecosystem, and so therefore these plants are antagonistic to nematodes. And an example of an allelopathic plant is the marigold, which is featured in the image on the right. So let's look at examples of cover crops that actually provide resistance to nematodes. So tomatoes are typically a host to melodogine, but when marigold, sesame, cowpea, or crotalaria are used as cover crops, there is a significant reduction of melodogine on tomatoes. Melodogine hapla has a wide host range, except for some of the members of the Poaceae or the grass family, which includes Sudan grass and oats. So these can be used to reduce melodogine hapla. Pratylincus penetrans also has a wide host range, but there are potentially resistant members in the family Asteraceae, so the daisies, Poaceae and Fabaceae, which is the legume family. Melodogine chatwoodi in the Netherlands loves to consume potatoes, sugar beet, carrots, maize, and other crops, but it is reduced in these crops when perennial ryegrass is used as a cover crop. However, crop resistance to one species of nematode may actually be a host to other root-feeding nematodes. So there have been instances where crotalaria has been used to reduce melodogine in a maize crop, but it increased Pratylincus Z, which also loves to feed on maize. So both these plants are hosts to Pratylincus, and this has happened to a point where the fields became unsustainable for maize production, but because of the reduction of melodogine, bean cultivation has become possible. So these are some of the gymnastics that can be played with the various cover crops that are available. And once again, the knowledge as to which plants and which plant families are susceptible to which nematodes is very important. And by far the best method to actually ensure that none of the root-feeding nematodes become an issue in the field is to grow a variety of crops all at once. So basically to grow a multi-species cover crop where the various families of plants are grown together. And if you want to see some awesome examples of what using multi-species cover crops results in for farmers, check out the Center for Regenerative Agriculture and Resilient Systems on the California State University Chicago website under the section of cover crops. Another fantastic way to ensure organic matter delivery to the soil as well as continuous support of the microbial soil ecosystem is to grow a low perennial cover crop continuously in the field while a cash crop is grown above it and harvested. And that cover crop that is grown perennially and constantly covering the ground can protect the soil while the cash crop is being harvested, and that cash crop must be able to be sown directly into that cover crop. And that is the best way to provide a constant supply of all the necessary exudates to feed the microbial community and keeping it in balance. And because perennial plants are of a higher successional order, they actually provide the soil ecosystem with a wider variety of microorganisms, and that includes various successional stages of nematodes, whereas at the lower succession end, where we plow the soil and remove plant matter from the soil, it kicks the system back to the beginning of succession. So there will always be this issue of having a potential imbalance in terms of proliferation of root-feeding nematodes. So having the ground constantly covered without actual disturbance via ploughing is the best method, ensuring a completely balanced soil ecosystem. And that balance through the continuation of plant exudates being supplied, as well as organic matter constantly being present in the soil and covering the soil and feeding the soil, is the best assurance we can provide against an imbalance of root-feeding nematodes becoming an issue. The other method to increase your organic matter in the soil is to use cover crops that are incorporated into the soil. So this is what we call green manures, and this supplies an increased organic matter in the soil, increased nutrients, as well as increasing soil quality and structure. Once again, plants that release toxins or other antagonistic compounds can be used, and green manure crops have been shown to increase parasitic, allelopathic, or antagonistic microorganisms as well that will naturally control the root-feeding nematode populations in the soil. Sudan grass, or Sorghum sudanense, has cell walls that have cyanogenic compounds in them, which via enzymatic degradation lead to the release of hydrogen cyanide, so they become toxic to root-feeding nematodes. And very low concentration of 0.01 parts per million of cyanide has been shown to significantly reduce Melidogine and hapla egg hatching and infection in lettuce roots. And here is an image showing the manual incorporation of some green manure into the soil. So some examples of using green manures include lettuce soil amended with Sudan grass residues, which has been shown to significantly reduce Melidogine and hapla infestation, but also increase head weight of the lettuce by 20% as opposed to control. Sudan grass residues have also been shown to increase carrot yields by 18%, and incorporating Sudan grass, oil radish, buckwheat, rapeseed, horse bean, velvet bean, castor bean, and maize residues into sterile soil significantly reduced Melidogine, chitwoodi, and some by up to 94% as opposed to controls. Oil radish and rapeseed green manures and crop rotation in potato fields have been shown to reduce Melidogine, chitwoodi, and increase yields by 185% as opposed to controls. Whereas Pratylincus neglectus is oftentimes unaffected by green manure treatments. So as you can see, this is quite a hit and miss situation, and the knowledge required has to be quite extensive. On the other hand, if we just look at it from the perspective of increasing organic matter in the soil and just wanting to really feed the microbial ecosystem, then it really doesn't matter what happens, as long as there is a variety of plants and as long as plants are constantly covering the soil. And I would highly recommend actually growing a multi-species cover crop using as many plant families as possible. And this will ensure that biodiversity is present. There is a distribution of the organic matter and exudates that is required to maintain a biodiverse soil ecosystem. And because any type of disturbance in the soil, particularly through ploughing, will actually decimate the predatory and omnivorous nematodes, the larger animals that actually prefer to feed on the root-feeding nematodes, it is best actually not to incorporate green manure into the soil. That's my personal opinion. And this is based on the fact that if you don't plow the soil, but actually keep increasing the organic matter by slashing the cover crop and changing the cover crop if it's an annual, and keep layering that organic matter, that residue, and then sowing directly into that organic matter once it's broken down a little bit, or finding methods of actually incorporating the seed directly into that slashed organic matter residue, there is no need to actually disturb the soil ecosystem, and then that just keeps feeding the system rather than taking it back in succession where only the bacterivorous, fungivorous, and plant parasitic nematodes can live. So what I would recommend is to actually have your cash crop, first of all, either growing above a perennial cover crop and preferentially multiple cover crops, if that's possible. If your cash crop is taller and can be harvested, then you've got a permanent organic matter / exudate provision to the microbial ecosystem in the soil. Alternatively, grow cover crops that are diverse, so a variety of plants, and slash them down each time and allow that organic matter to stay there. The other great benefit of that is you have the roots remaining in the soil as well, and those roots are a constant supply as they decay of organic matter to the microbes, plus keeping the soil in situ, preventing erosion. There's just so many benefits to having that system where you never plow the soil, you only direct drill seed into that soil. And that is basically what I would recommend. I wouldn't recommend really green manures, even though they are fantastic compared to controls where there's no incorporation of organic matter into the soil at all. But really having that constant cover and constant chop and drop on top of the soil, and especially with variety of plants from different families, I would say that that is the least labor intensive and the most beneficial way to grow crops. And this organic matter that feeds the soil through the residues as well as the exudates being constantly supplied, as well as maintaining some level of biodiversity, is what really will keep that soil ecosystem healthy and balanced so that root-feeding nematodes remain at low ratios within that soil ecosystem. So we have come to the end of lesson 7.14, and in our next lesson we'll focus on predatory and omnivorous nematodes. And these guys are very beneficial in the soil, being primary predators of root-feeding nematodes. Okay, so you'll be hearing from me again in lesson 7.15. Bye for now.